25 billion kilometers from where you are sitting right now, a machine built in the 1970s is still awake. It has no screen, no crew, no way to feel the cold that surrounds it, a cold so deep it would freeze the very idea of cold. And yet, once every few days, it does something almost unbelievable. It listens for a whisper from Earth, and it answers back. That machine is Voyager 1. It launched in 1977 before most of the people reading this script were born, before the internet, before cell phones, before anyone knew what a black hole actually looked like. It was built to last 4 years. It has now been flying for almost half a century. But here's the part most people don't know. Right now, in laboratories in Southern California, a small team of engineers is fighting one of the strangest battles in the history of space exploration, a battle against electricity itself. Voyager 1 is running out of power. Not next year, not in some distant future. Now. And every choice they make, every instrument they shut off, every system they gamble on, could be the decision that either keeps humanity's most distant emissary alive, or silences it forever. This is the story of that fight. To understand why this moment matters, you have to understand what Voyager 1 really is. It's not just a satellite. It's not just an old piece of hardware drifting in the dark. Voyager 1 is, quite literally, the furthest a human-made object has ever traveled. It flew past Jupiter. It flew past Saturn. It sent back the first close-up images of moons we had only ever seen as dots of light. Then, in 2012, it did something no spacecraft had ever done before. It crossed the Heliopause, the invisible boundary where the sun's influence ends and true interstellar space begins. Think about that for a second. Voyager 1 isn't just far away. It is outside the bubble that protects our entire solar system from the radiation of the galaxy. It is out there, alone, in the space between stars, and it's still talking to us. Bolted to its side is something almost poetic. The Golden Record. A gold-plated copper disc designed by a team led by the astronomer Carl Sagan, carrying greetings in 55 languages, sounds of Earth, and pieces of music from across human history. It was built on the idea that someday, something, or someone might find it. It was humanity's message in a bottle thrown into the largest ocean there is. For nearly 50 years, Voyager 1 has been our voice out there. And for nearly 50 years, it has kept working far longer than anyone thought possible. But nothing lasts forever. Not even Voyager. Here is the simple, brutal truth engineers at NASA's Jet Propulsion Laboratory are dealing with. Voyager 1 is dying of old age, 1 watt at a time. The spacecraft is powered by something called a radioisotope thermoelectric generator, essentially a chunk of decaying plutonium that produces heat, which is converted into electricity. It doesn't need sunlight, it doesn't need fuel in the traditional sense. It just needs the plutonium to keep decaying. And it will, for centuries, actually. The problem isn't that the power source is failing suddenly. The problem is that it decays a little every single year, and Voyager 1 loses roughly 4 watts of usable power annually. 4 watts doesn't sound like much, but when your entire spacecraft runs on a power budget smaller than a household light bulb, 4 watts is the difference between an instrument working and an instrument going dark forever. For years, engineers have been managing this decline the way you'd manage a slowly leaking boat. Patch what you can, keep just enough afloat, and accept that some things eventually have to go overboard. They've turned off heaters. They've turned off backup systems. They've turned off instruments that were once considered essential to the mission's scientific value. Each shutdown buys time, months, sometimes years, but each one also means Voyager 1 sees a little less, senses a little less, tells us a little less about the universe it's traveling through. And in the spring of 2026, they had to make one of the hardest calls yet. In February of 2026, during a routine maneuver, something happened that made engineers' stomachs drop. Voyager 1's power levels fell unexpectedly, more than they should have. For a spacecraft already living on borrowed watts, an unplanned drop like that is terrifying. It brings the probe dangerously close to triggering something called undervoltage fault protection, an automatic safety system that shuts down components on its own to keep the spacecraft from destroying itself. That might sound like a good thing, a built-in safety net. But here's the catch. If that fault protection system ever triggers on its own, recovering from it isn't simple. It can mean days or weeks of painstaking work, sending commands across billions of kilometers, waiting nearly a full day for each one to arrive and hoping the spacecraft responds the way it's supposed to. In the worst case, an automatic shutdown could cascade into something the team can't reverse at all. So NASA made a preemptive move. In April 2026, engineers made the call to permanently power down one of Voyager 1's remaining science instruments, the Low-Energy Charged Particles Experiment, known as the LECP. This wasn't some minor gadget. The LECP had been running almost continuously since launch in 1977, nearly 49 unbroken years of data. It measured charged particles, ions, electrons, cosmic rays, streaming in from both our solar system and from deep interstellar space. It was one of the primary reasons Voyager 1 was still scientifically valuable at all, because it and its twin, Voyager 2, are the only spacecraft ever to gather this kind of data from outside the sun's protective bubble. And they turned it off, on purpose, to keep the rest of the spacecraft alive. Try to imagine that moment in the control room. Nearly 5 decades of continuous measurement ended with a single command transmitted across the solar system, arriving at a machine so far away that the engineers wouldn't even know if it worked until the next day. It's not the kind of moment you see in movies, with alarms blaring and countdown clocks ticking. It's quieter than that. It's sadder than that. It's a team of scientists, essentially performing a form of hospice care on a piece of hardware they've spent their entire careers with, deciding organ by organ, system by system, what the spacecraft can afford to lose in order to keep its heart beating just a little longer. But this isn't just a story about turning things off. It's also a story about engineers trying something bold, something almost defiant, to buy Voyager more time. The team has been testing an unusual workaround, something engineers nicknamed among themselves with characteristic dark humor. The idea is to find creative ways to squeeze more operational life out of systems that were never designed to run this long, this cold, or this low on power. The plan was to try the fix first on Voyager 2. Why Voyager 2 first? Because it has a little more spare power and it's slightly closer to Earth, which makes it the safer spacecraft to experiment on. If something goes wrong, the team has a better chance of catching it and recovering. Voyager 2 became the test subject, the guinea pig, for a procedure the team hoped could eventually be applied to its older twin. If the test succeeded, engineers planned to attempt the same approach on Voyager 1, and there was even a flicker of hope buried in the plan. If the fix worked well enough, there was a chance, just a chance, that the instrument they'd shut down in April could someday be switched back on. That's the emotional core of this entire mission right now. It's not a story of simple decline. It's a story of a team refusing to let go without a fight, testing every possible way to squeeze a few more months, a few more years, out of a machine that has already outlived every expectation ever placed on it. To understand just how difficult this work is, you need to understand the sheer, almost incomprehensible distance involved. Voyager 1 is now so far away that even light, the fastest thing in the universe, takes an enormous amount of time to reach it. In November 2026, Voyager 1 will cross a milestone no human-made object has ever reached before. The point at which a radio signal traveling at the speed of light takes a full 24 hours just to arrive. Let that sink in. Not 24 minutes, 24 hours. NASA's own project manager for the mission described it in the simplest possible terms. If you send a command and say, "Good morning, Voyager," at 8 o'clock on a Monday, you won't hear anything back until 8 o'clock on Wednesday. A single good morning and its reply take 2 full days, round trip. This is what the engineers are working with. There is no live troubleshooting. There is no quick fix, no rebooting a system and watching it come back online in real time. Every single command sent to Voyager 1 is an act of faith, a message thrown into the dark with the answer arriving 2 days later, whether the news is good or bad. Imagine trying to perform delicate surgery, except every instruction you give takes a full day to reach the surgeon's hands, and you don't find out if the patient survived until a day after that. That is the reality of keeping Voyager 1 alive. It isn't a control room drama with instant feedback. It's something slower, stranger, and in its own way far more suspenseful, a chess game played across billions of kilometers, where every move takes days to land. You might be asking yourself, why does any of this matter? It's an old spacecraft. It's not coming back. Eventually, no matter what NASA does, Voyager 1 will fall silent. So why are so many people fighting so hard, for so long, over a machine that was only ever built to last 4 years? Because Voyager 1 isn't just hardware. It's memory. It's proof. It's proof that human engineering, built with the technology of the 1970s, computers weaker than the one inside your microwave, can still be operating flawlessly across a distance that defies imagination. It's proof that Curiosity, once launched, doesn't have to stop just because the mission's original goals were met decades ago. And there's something else, something harder to put into words. As long as Voyager 1 is transmitting, humanity has a voice out there, past the edge of our own solar system, drifting through the space between stars. The golden record is still attached to its side, the music, the greetings, the sounds of Earth. They're still traveling with it, whether or not the transmitters are still on. But as long as Voyager 1 can talk back to us, it means we're not just observers of the universe, we're participants in it. We reached out, and something we built is still reaching back. Every watt the engineers save, every instrument they carefully power down, every experimental fix they test first on Voyager 2 before risking it on Voyager 1, all of it is an attempt to keep that connection alive for just a little longer. Not because the mission needs more data, necessarily, but because as long as Voyager 1 is listening and responding, it represents something almost sacred. The idea that what we build can outlast us, outlast our expectations, and keep going long after everyone said it should have stopped. The honest answer is nobody knows exactly how much time is left. Voyager 1 has already defied nearly every prediction made about it. It was supposed to last 4 years. It has lasted almost 50. Engineers have already survived one major crisis. Back in late 2023, the spacecraft began sending back a signal that looked normal on the outside, but contained no usable data at all. The result of a fault in one of its onboard computers, a problem the team eventually traced and worked around after months of painstaking long-distance detective work. If they could solve that mystery from billions of kilometers away, using nothing but faint radio signals and immense patience, then perhaps this power crisis, too, has more room for creative solutions than it first appears. But the physics of it are unforgiving. The power will keep declining. There is no way to refuel a radioisotope generator floating in interstellar space. Eventually, instrument by instrument, heater by heater, system by system, Voyager 1 will run out of things it can afford to lose. At some point, maybe in a few years, maybe longer if the team's experimental fixes keep working, there won't be enough power left to keep the transmitter itself running. And on that day, for the first time since 1977, Voyager 1 will go quiet. It won't stop existing. It won't stop moving. It will keep drifting outward, carrying the golden record, carrying humanity's greetings and music and hope for millions of years after every one of us is gone. But it will stop talking to us. That is the quiet, almost unbearable truth sitting underneath every decision NASA's engineers are making right now. They are not trying to save Voyager 1 forever. Nobody can do that. What they are trying to do is make sure that when the silence finally comes, it comes on their terms. Planned, understood, and as late as humanly possible. Not from a sudden fault, not from a mistake, but from the simple, honest exhaustion of a machine that gave everything it had, far longer than anyone ever asked it to. Somewhere out past the edge of our solar system, in a cold so total it's difficult to even picture, a nearly 50-year-old spacecraft is still listening for us. Every few days, a message leaves Earth, crosses the orbits of every planet we know, passes beyond the boundary where the sun's influence fades into nothing, and finally reaches a machine that has been alone longer than almost anything humans have ever built. And somehow, against every reasonable expectation, it still answers back. The engineers working on this mission today weren't even born when Voyager 1 launched. Some of them have spent their entire careers caring for a spacecraft older than they are, learning its quirks, its failing systems, its stubborn will to keep going. They are not just doing a job, they are keeping a promise made in 1977 that this small gold-plated messenger would carry a piece of us out into the universe for as long as it possibly could. We don't know exactly how many chapters are left in this story, maybe a few more years, maybe longer, if the fixes keep working and the watts keep stretching just a little further than they should. But for now, Voyager 1 is still out there, still listening, still answering. And somewhere in Southern California, a team of engineers is still doing everything humanly possible to make sure that when they say good morning to a spacecraft billions of kilometers away, it still, somehow, finds a way to say good morning back.